Roger, Roger. We have a beautiful signal down towards Louisville. We're just across the river from Louisville in Indiana, Roger.
Oh, okay, very good, very good. Well, you got a great signal here. You're about 5 to 10 over, depending on a little bit of QSB here. So doing a good job. I just could not pull the other station through. I don't know if you could hear them or not, but just way down in my noise floor. It's strange. Conditions are not very good right now, but every once in a while things just shift, and it shifts within seconds, and you just never know. I'm running an ICOM 7600 here, Jim, to an ACOM amp, about 550 watts out. And I've got a NFED 80, no, but that's a different one. I got an NFED 160 through 40 meter. I got two NFEDs here. This is a 160 through 40 meter NFED, about 45 feet up in the trees. KC9VKV, AK3Y.
Roger, Roger. Sounds good, man. One of the strongest signals today. Obviously, the band is up and down. I was talking to a guy up in North Carolina running 400 watts, faded out. I mean, 20 dB excursions on the band, so it's not a good day.
No, that's for sure. That's for sure. No, what amazes me, Jim, is the rapidity at which the band's conditions shift, and that's the physics behind that's got to be really interesting. But the fact that you could be talking to somebody 20 over 9, and then within seconds, I mean, literally within seconds, he's down to the noise floor. It makes you wonder exactly how that signal is bouncing off the wire. Over.
Roger that. We're running right at a KW. What is your power?
I've got about 550 watts out right now.
Roger that. And where are you location?
Okay, I am exactly 35 miles from the White House. So if you go north-northwest from the White House, 35 miles, that's where I am. I'm right on the Potomac River. Well, I shouldn't say exactly right on it, but within a block and a half of the Potomac River and the C&O Canal. And right across from the other side of the Potomac River is the state of Virginia. So we're very close to the state of Virginia line, and just inside Maryland on the northwest side. Over.
Roger that. Roger that. I was just curious, man. Your signals. Yeah, I'm looking at the output of my receiver, which is a Yaesu 990. Looking at it on a view meter, and you are 70 dB above my noise level, Roger.
Oh, okay, very good, very good. Yeah, you're sounding very good over here, by the way. I may have come across you when I was putting in the band. I heard a very strong 9 station. It might have been you, and if it was, I think you were talking with another gentleman about audio issues with his transceivers. Was that you, Jim?
Yeah, Roger.
Oh, okay, very good. I actually was playing around with his signal, and I use a program. I don't know if you've ever tried that one. It's a program called Audacity, and what's nice about Audacity is that with the ICOM 7600, I can essentially interface with it directly through the USB port, and it'll record directly off of that. I can adjust it so there's no clipping. And then from there, I get a polyspectral density. I can get the waveform data output. Very, very nice piece of software. And plus, unlike the bare ICOM, I cannot play back signal easily that I hear. But with Audacity, I can do that through the digital port, which is kind of a nice feature of it.
Roger that. We are recording our QSO-VLOG today. And we have a YouTube page for QSO-VLOGs. If you go to YouTube and do a call letter search for Kilo Charlie 9 Victor Kilo Victor, that would bring up our QSO-VLOG page. And right at the top of the page is one that's got about 170 QSOs. And if you click on that, that'll bring up the whole slew of them, all of them actually. And Art Bell is at the top, and then our QSO right now would probably be right close to the top. Roger?
Oh, okay, very good. In fact, I'm just doing that right now, just see if I can get to that page. Let's see. I've got you as Jim Ferguson's radio story. Let's see, is that where I look? I'm not a big YouTube aficionado, so I'm not sure exactly what to click on here. But is it the Jim Ferguson's radio story, or is there oh, I see. There's a vlog. Maybe that's it. Am I getting close?
Yeah, the radio story is our homepage where we have about 700 entities that we celebrate a 50-year broadcast career. But the one that we would be interested in is the QSO-VLOG, which is right at the top of the page. It's one that shows 170, Roger, or thereabouts.
That I don't see the 170, and maybe it's just that I'm not really looking in the right spot. I got a bunch of stuff here. I will find it. I'm not going to waste your time doing it, but I can see a bunch of RS numbers, and I got RS 1422, RS 1432, blah blah blah, et cetera, et cetera, et cetera. There's a gajillion of them here, and maybe I need to search a little bit differently here.
Roger. Well, if you go to YouTube and you do a call letter search, Kilo Charlie 9 Victor Kilo Victor, that will bring up our QSO-VLOG page, and right at the top one would be the one that shows 170 or some 160 or 170 QSOs. It's got black on the right-hand side with a number in it. Roger.
Okay, I will find it. I won't kill your time doing it right now, but I got it. I got it here. Very good. I now see where it's located, so we're getting there. Yeah, I'd be happy to. That'd be fun to look at. So where were you doing your broadcasting, Jim?
Oh, well, gosh, a little bit of everywhere. We started down in Florida in a little town called, they always say go to the boonies, and at 15 I hopped a Greyhound bus with $50, and I made it to a place called Pahokee, which is just on the southern rim of Lake Okeechobee in Florida. And that's when they called the station WRIM, and it was during summer vacation at school, and there was a couple of the employees of WRIM were taking vacations, so it just worked out that I got to work at that station for a couple of months. I did morning sign-on and afternoon from 2 to 5, I think it was, as I recall. And that was when I was 15, so blah, blah, blah. And wound up in North Carolina, worked at a couple of stations there. And one of the stations had a parent company called Radio Smiles, which owned 7 stations, so I became group production director for that entity. And so then I had a chance to go to WHAS in Louisville, which is a 50,000 watt clear channel station before iHeartRadio Clear Channel. And I was a production director for WHAS radio from 1970 to 1979, Roger.
Very good, very good. Nice career. WHAS I used to hear every so often from Chicago. I was born and raised in the Chicago area, got my first call in that spot, and I used to do a lot of AM broadcast DXing, and I don't know why I enjoyed it, but it was kind of fun looking for some of the weak signals, and the WHAS was not a weak signal, but even today I can hear the WCFL and WRS stations over here on this radio, but it's fun. Very good, very good. My career has been in electrical engineering, mostly communication systems, small radar systems, and so I retired about 10 years ago from that. I had my own business for about 25 years prior to doing that, and I'm glad to be retired. It was fun for a while running a business, but after a while, you get to the point where you're not doing what you really want to do, and because you're doing mostly hand holding. So that was that's sort of where it ended up at the end. But we had a fun time with it and enjoyed it. I did mostly work up in the microwave bands in the 5 to 20 gigahertz region. So that was where our forte was. Jim, KC9VKV, AK3Y.
Roger. Well, maybe you could elaborate on small radar systems. Would these be like in airplanes or fixed locations?
What we ended up doing was building specialized units for Special Operations Command use and a couple other agency use. These were radars that had a very, very fine resolution on the order of a couple inches. and they were very, very small, handheld. I mean, literally handheld. And we had done some stuff with the Department of Transportation with them. Initially, some of the thought was from the commercial perspective, was to use it for the intelligent highway system work that Virginia Tech was doing at the time. And we played with some of those for that application. But then what ended up happening is, as we started doing that more and more, we realized that the more interesting area was in tracking. And so we ended up building tracking systems that we used for determining where personnel were located in facilities like hospitals, and one of the big areas was in power plants and oil refineries, where there's lots and lots of metal. These little radars had the unique ability to get around metal pieces very easily without lots of reverberation, which you get in some of those very dense environments. So anyway, kind of an interesting spin. And today, our little geolocation tags are actually used in the NFL. They've got them in all their shoulder pads. So that was kind of a fun project we had with the NFL a number of years ago. KC9VKV, AK3Y.
Roger, now explain to me how you could use radar in shoulder pads. What did it measure?
What it was a triangulation system that would send out a very short burst, typically about 1 to 2 nanoseconds. So it's a very, very, very tiny burst of energy. And that would be received. It's not the tags that we use were not radars in the sense that we were looking for a return signal. What they were basically similar to what you would have with GPS. So in other words, the transmitter would ping out a pulse. There will be multiple receivers that would pick out that pulse. And based on the time difference of arrival at the individual receivers, you could triangulate where that particular tag was located from a couple inches of no resolution. Now, the same technology was used in the radars, but in the radar case, what you're looking for is a return signal off of an object, and then the receiver would be located at the radar itself, so you can get a return that would be measured right where you're transmitting, whereas in this case, the returns were measured, or the energy was measured at a far apart location that you can triangulate from chips. I hope that makes sense over to you.
Roger. I just wonder if, well, I've seen some radars down at the border where, there'd be an 18-wheeler going across the border with, their trailer, and they could actually shoot radar through the trailer and see all the inhabitants inside the trailer, Roger?
Oh, yeah, exactly. And it's a function of a couple things. Certainly the frequency of operation is important. The bandwidth is important. Things of that nature. We had a company that we were competing with at the time, but they did some interesting stuff with through-wall radar sensors. And their goal was to build a unit for police that can see people through, all kinds of obstructions. And it worked fairly well. The technology was called ultra-wideband, and the reason for that name was that the instantaneous bandwidth, the transmit bandwidth of most of these waveforms was half a gigahertz to a gigahertz. So it's, compared to us working with 3 kilohertz, think of something that's a gigahertz wide, and that's sort of what the technology was over.
Oh, Roger. Yeah, I think in the Boston bomber case, I think they used something like that to look in the inside the boat from the air. I believe they had a unit like that.
Yeah, I think that's correct. I don't know exactly the technology there, but I remember seeing some of the radar returns from that on television when they were broadcasting that, and it looked very similar to what's being done with those types of radars. The military's used them for a number of years. The technology really got started probably in the mid-1960s, early 1970s, but it wasn't really perfected until much, much later. And then it took, in order to get some of those commercial applications, of course, you have to go through the Federal Communications Commission, and that took a number of years to finally get the technology approved. And I think in 2000, I think it was, or 1998, somewhere in that time frame, I can't remember exactly year, but the FCC came down and gave permission to use the technology in various frequency bands. And at that point, a lot of interesting devices were made. But I think the initial applications were to be able to look through different types of materials, and also to determine. I think one of the early articles I saw was the ability to determine stealth materials. In other words, to be able to detect stealthy type of targets using these very wideband stuff, and that's all the unclassified stuff that is available to look at. KC9VKV, AK3Y.
Roger, Roger. Now the unit that shoots a signal, would that be like a handgun kind of thing?
It can be. The way that this one company built them was actually sort of liquid crystal display that would show the radar return in real time. And it basically did a little bit of scanning so that you could essentially see azimuthal and range information simultaneously. And so the display was such that it was large enough that you really ended up with a box that you'd hold with both hands rather than something where you'd shoot like a radar gun that a police officer might have over.
I got it. Are you still active in that area now?
No. I sold my business to the company in Chicago in 2008, and they took over taking that technology forward from that point. But I worked in that area for about, probably about 20 plus years, and so we developed lots and lots of different widgets and interesting things. One of the interesting things was that we did some very long range HF communications using very broadband waveforms. The waveform that we used actually covered the entire HF spectrum with one single burst. And from that we pieced it together, because each frequency has a little different delay as it goes through the F layers. And some of the frequencies don't make it through the layers, and as we know with the sunspot cycle going down the toilet. But from that we pieced together the signal at the other end, and we're able to get with very little power, microwatts of power. We were able to get about 1,000 miles of communications range. So that was kind of a fun project of it.
Wow! And you could actually, I guess, stop the wave and take a picture of it, Roger?
Well, what we did was, each frequency had to be, basically, it was digitized. So this is a sort of an early version of a software-definable radio on the receive side, but it had an A to D converter, a very high-speed A to D converter that would take all the data and then frequency, basically take it apart from a frequency perspective, readjust the waveform, and then superimpose things together to get the resulting pulse. So it was an interesting project. That was the one that we did. Another one that you might find fun. We had a project with ESPN a number of years ago, and they wanted a device that could measure how high the skateboards would go in the QRX-1. Here, second, Jim.
This is Kilo Charlie 9 Victor, Kilo Victor.
I just got to call for lunch, so I won't keep it too long. But so we had we had two little devices in the bottom of the skateboard, one at the front, one at the back, and a receiving setup that would measure the returns from those little transmitters. And as the skateboard would go up in the air, you could measure the centroid of where the skateboard was to within about an inch of resolution. So they use it in the X Games to get the height above ground for the skateboard. And so all kinds of interesting applications of this wideband technology.
Roger, Roger, Bob. Well, it certainly is an interesting career there, and right on the cutting edge of developing different things to be useful in the commercial world. So good going there. And how long have you been a ham there, Bob?
Oh, I'm a new guy. I've been a ham for 53 years.
Great. Well, listen, I won't keep you. I don't want anybody to be late for lunch. So I'll say threes to you, Bob. And like I say, we'll be posting this QSO in the next couple of days, Roger.
That sounds great, Jim. I'm looking forward to playing that. And a great meeting you. I hope we get a chance to continue again sometime soon. Have a great weekend ahead, and thanks so much for the QSO, Jim. KC9VKV, AK3Y.
Roger, Roger, Bob. 3 is that away. Catch you later. KC9VKV.